Today we are discussing the interconversion of matter. Just now you have seen that we were having camphor which was in the solid state, and just now we are burning it. So normally the interconversion of matter takes place, means solid can be converted into liquid, liquid will convert into gas. Here solid will not convert into liquid, but it will directly convert into gaseous state. You can see the smoke coming out of the camphor, and we will see that after it burns there will be no residue, means directly the solid has been converted into gaseous state, which is known as the sublimation. Camphor, ammonium chloride, this type of substances are showing the property of sublimation. Process is sublimation and the compound is sublimate. You can see after the camphor burns completely, there is no residue. This technique of sublimation is useful to separate the mixture of ammonium chloride with any of the powder, and whenever we will heat that, this ammonium chloride will sublimate, and after cooling it will be deposited to the funnel, which we can get back, and the remaining substance will be in the watch glass. Hello students, we are having a glass, a cardboard and a 5 rupee coin. Just now the cardboard and coin both are at rest. Now I had flipped the cardboard. You can see that coin was at rest. It does not want to come in motion. So the card is flipped, but the coin falls in the glass. So students, just now you can see that the rainbow with your color, and this is the prism which is kept in front of the sunlight. So the light falls on that, and it is divided into its 7 components. Hello students, let us understand the types of friction. We are having 3 types of friction: static friction, sliding friction and rolling friction. We have discussed that friction arises due to the irregularities in the surfaces. Just now we are having this surface, 2 objects, this lead and this box are kept on this surface. They are not sliding, they are not rolling. That means just now they are having this static friction. These objects are at rest on this surface. If I want to measure that how much static force this surface is applied on these 2 objects, then we are having one instrument which is known as spring balance. This spring balance is if tied with any object and if we are pulling that, then this spring will move, and as a result we can see that how much force is applied by the object. So let us try with these two objects. For this first object, as you can see that it is moving very easily. Now let us try with this box. You can see that in this case the box does not move so easily, and here the spring is showing the reaction. You can see the movement of the spring. So we can understand that mass of the object is also equally responsible for the frictional force. Instead of this static friction, if I will push this object, so now it has been started sliding. So the sliding friction, when the object starts sliding, the resistance offered by the surface. So this we are sliding the object, and still if I want to reduce the force, then we have discussed that we are having the roller. You can see over here that this is having the rollers in the form of wheels, and this is moving comparatively very faster, and these rollers are made with the help of toothpick and the lids of the bottle. So here we can conclude that static friction is highest, less than that sliding friction, and the least frictional force is rolling frictional force. If we want to check the roughness or smoothness of the surface, then I am having two cells. One is having plain surface and another is having the surface coated, wrapped with the sandpaper. So I am trying to roll down these both. You can see that this cell is rolling very easily,